Hopefully, everybody wrote down.
This is Sharon.
And sometimes HL. Most of the time, we are just dealing with four options. If it's not a right triangle, then you have four options. If it's a right triangle, then you have five options. For some reason, people are assuming that the right triangle ones are always HL. They're not always HL. That's just another opportunity or alternative answer that you could have. Only go by the given information. They're telling me that AD and BC intersect and that AX goes with XB, CX goes with XD. Don't put anything into the drawing unless you have a justification. Do I have a justification for doing that? Yes, I'm allowed to do that because I got vertical angles. So as a result, I do have congruent triangles. What corresponds with A? B. Don't go by positioning, actually go by the slash marks. They are led to the X by slash marks 1 and 1 there. So A goes with B, that rolls out these two. C goes with D. Choice C. Correct. Same with number 2. I want to only go by the information that's in this chart. They're telling me that A corresponds with C. They're telling me that AD goes with BC. They're telling me that AB goes with this. So I'm only using that information. What would we normally put in the center? What kind of property? Reflexive. They're not showing that on there, so we're not using that. We're only using what's here in this little universe that they've created. So given that information, what am I looking at? I'm looking at an SAS situation. The congruent part isn't really the important part. The important part is the letters. They correspond. D goes with J. So D goes with J. E goes with F. E goes with L. And F goes with K. As a result, that means that this side corresponds with this side. What value of X makes equal? So that's got to be 6. Make sure that you notice correspondence in your congruent statements. Which pair of triangles can be proven congruent by side angle side again? Notice the symbol. We've got, if I blew that up a little bit, you'd see an arc with a little slash mark in it. That's another way of showing that angles are congruent. You see that in different textbooks. I haven't seen that shown up on a SOL test, but it's possible that that might show up. It just means that our angles are congruent. Which is not congruent to the other 3 triangles. Anytime you got 2 angles in a triangle, always finish it off. 60, 70, 50, 60. We're interested in having the 9 surrounded by the same angle pairs. 50 and 60, 50 and 60, 50 and 60, not 50 and 60. That is the one that is not congruent. On the back page, the triangles that we're interested in are QSR, QSR, and TRS. TRS. So it's not the thin one up here. Up here, it's these two at the bottom. I'm going to jump right to my choices here. Let's see. Reflexive property is usually easy to find. Do we have a reflexive property anywhere? Do we have something equal to itself? So I know I've got reflexive property. I don't really care where all this is leading to. But I know that that's reflexive property. I know that the final answer either has to be side angle side or ASA. So it's either SAS or ASA. I don't know yet. When would I be using CPCTC? Would I use it for this one? No, it would be the next step, and they're not showing any next steps. So I know this is not B. So I've already used these two up. What's the only one left that I haven't used? Base angles of an isosceles triangle. Does this mention angles? Yes. That would be choice A, base angles, congruent. Well, now let's actually take a look at the drawing and see which one of these two I want. If I look at the given information, PRPS. PRPS is this and this. That's not actually part of the two triangles I'm looking at. But that tells me that I have what kind of triangle, that equals that. Isosceles. If I've got isosceles, that means that this big angle S right here is equal to this big angle R over here. So in this drawing, these two are the same. And we say with reflexive property that equals that. Is there anything else that's given to us that is helpful? Oh, I'm not looking at the right triangles, am I? QSR, TRS, oh. No, I am looking at the right triangle. Oh, right there. Two angles. QSR. QSR is the little angle right here. And TRS, the little angle right here. So I'm looking at angle, side, angle. The one I want down here is ASA, which is tomorrow.